So implicit functions. Okay. This gets a little bit complicated, and I'm going to be completely honest. I don't know exactly what an implicit function is, as in I don't know the definition, but I can still tell you how you can probably define or find what is an implicit function or an implicit function problem if it's not specifically stated that it is or isn't. So, first of all, what is an implicit? Or what is explicit? So, normal functions I get, y equals f of x, that's explicit, right? You have y just on its own, and it is determined by some function of x, right? Just one variable, x. So that is an explicit function. Implicit's a bit different. Implicit functions use two variables. So what you'll probably see, in most, not super advanced classes, you'll see y to the power of x and y to the power of n. So y to the power of whatever. N just means, any value, y cubed, y to the fifth, y to whatever. And also x to whatever, and that will equal something. It could equal 0, it could equal a number. And that's an implicit function because it depends on both the variables, right? Both the variables have to be inputted in. It's not like an explicit function where you just put in the x variable and with that you find y. With implicit, you have to put in both. So for example, this equation right here, which I just made up, I don't know what that looks like if you actually graph it. This is an implicit function because you have to put in the values for both x and y. But if that doesn't make any sense, basically, if you see that y is like cubed or it's like x multiplied by y and you see y in multiple different places, it's an implicit function. That's, the straightforward way. And most likely you won't even have to try to identify if it's implicit or not because it will just say in the question, find the derivative of this implicit function or something like that. So, jump scare. Yeah, big, scary equation. This probably looks really complicated and bad. But if you break it down and follow along with me, you'll hopefully realize that this is actually pretty simple. It's just a lot of steps, and you just need to make sure you know how to properly expand, properly do algebra. And if you can do that, then this is actually pretty easy. If you can't do that, if you have problems with expanding in algebra, then all I can really suggest is you practice, because you just keep practicing and you'll get better. So with that being said, let's take a look at this. So the original equation that we're giving, implicit equation, is 2x cubed times y plus y squared plus x cubed is equal to x to the fourth power. So we're supposed to find the derivative of this implicit function. So what are we going to do? So the first step when you're finding the derivative of an implicit function is to find the derivative of each term. So first term, 2x cubed plus y, we're going to find the derivative of that with respect to x. Second term, y squared plus x cubed, we're going to find the derivative of that with respect to x. Third term, x to the fourth, we're going to find the derivative of that with respect to x. So the way I like to do it, and the way I highly recommend doing it, is you look at each term individually and separately you find the derivative of it. So in this case, as you can see, I put this purple star here. So this specific term right here, the derivative of 2x cubed power y with respect to x, I solved it right here. So we're going to start by just looking at that. So we have the derivative of 2x cubed times y. So first thing we're going to do, we're going to pull the 2 out, right? Because the 2 is a constant before the actual variables. So you pull it out to the start. So you now have the derivative of x cubed times y with respect to x. So this is a product, right? We have x cubed and we have y. So the product is x cubed times y. So we're going to use a product rule. Well, for the product rule, we need to find u and v, and then we need to find u prime and v prime. So u in this case will be x cubed, and v in this case will be y, right? Because x cubed times y, x cubed times y, x cubed is u, y is v. Straightforward. And then we need to find u prime and v prime. So u prime is 3x squared, right? That's just power rule, x cubed, the derivative of that, 3x squared. V prime is dy over dx. And the reason why is because, well, you're finding the derivative of y. So if you were, so earlier, for example, we took x4, we're finding the derivative of it. We put dx4 over dx. Well, if you're finding the derivative of y, you're just going to get dy over dx, right? You put that in, dy over dx. The derivative of y is dy over dx. So that's what we have. So now you're just going to do the product rule. So first of all, of course, we have 2 to start because we pulled it out. So 2. So we take u, which is x cubed, multiply it by v prime, which is dy over dx. And then we take u prime, which is 3x squared, and multiply it by v, which is y. So we get this. And then down here, I expanded it. So when by expanding, it's going to, put the 2 into the terms. So we have 2x cubed dy dx plus 6x squared y. So far, I hope that was at least just, pretty simple algebra. We applied the product rule, and then after that, you just expand. Next, we're going to look at this second term, which is the derivative of y squared plus x cubed with respect to x. This one is maybe a bit more complicated, definitely more steps. We're going to have to use the chain rule here. So the chain rule in this case, because we have y squared plus x on the inside, and then we have to the power of 3 on the outside. So we're going to say that y squared plus x is u, right? We have u equals y squared plus x. And then we're going to find the derivative of u prime. So the derivative of u is 2y times dy over dx plus 1. So the plus 1, straightforward. The derivative of the derivative of x is 1. So that's easy. The derivative of 2y derivative of y squared is equal to 2y times dy over dx. So whenever you're doing implicit differentiation and you are finding the derivative of y, or y squared or y cubed, whatever, derivative of y of anything. Long story short, the way you treat y in implicit differentiation is you find the derivative of it as if it were x, right? So you find the derivative. So in this case, you find the derivative of 2y as if it was, y squared, as if it was the derivative of x squared, which is 2y, and then you multiply it by dy over dx. That's the simple way to do it. That's how you should do it, like, every time. So if we had, y cubed here, then it would be 3y squared times dy over dx, right? Because you'd find the derivative of y cubed as if it was x cubed. So, pull the 3 back, 3y squared, and then you multiply by dy over dx. Anytime you're differentiating y in an implicit differentiation, you just differentiate it like normally as if it was x, and then you multiply it by dy over dx. That's it. That's all you have to do. And so now that we've done that, we apply the product rule. So the derivative of y with respect to u times the derivative of u with respect to x. Well, the derivative of y with respect to u. So we know what u is. U, y squared plus x. And the derivative of y with respect to u, well, y squared plus x is cubed. So it's 3 times y squared plus x squared, right? We take the 3, bring it to the front, and then the power goes down by 1, right? It's just power rule. And y squared plus x is u, right? We're finding the derivative of y with respect to u, and so that's why we just have y squared plus x here. And then you multiply it by the derivative of u with respect to x, which is u prime, right? We just found it. So we take that and multiply by this. At this point, it's a lot of expansion, right? A lot of expansion, looks pretty scary and complicated. But again, as long as you know how to expand, as long as you can do your algebra, this is literally just, any regular old math expansion problem. I'll go through it here. So y squared plus x. So this is the same as y squared plus x squared. So this is the same as a plus b squared, and a plus b squared, of course, expands to a squared plus 2ab plus b squared. So we get y to the power 4 plus 2y squared x plus x squared. and then the second one I left alone for now. So now we have all this in brackets, and we have all this in brackets, and they multiply by each other. So now we're just going to do regular bracket multiplication, FOIL, basically, except in this case we have 3 terms here instead of 2. So you're going to take y to the power 4, multiply it. So this is the first term here, right? Y to the power 4 is the first term in this bracket. You're going to multiply it by the first term in the next bracket. You have 2y to the 5th times dy over dx. Then you're going to take the first term again here and multiply by the second term of this bracket, which is just 1, so it just stays the same. It's y to the 4th. You're going to take the second term of this bracket, multiply it by the first term of the second bracket, second term of the first bracket, multiply by the second term of the second bracket, third term of the first bracket, multiply by the first term of the second bracket, third term of the first bracket, multiply by the first term, by the second term of the second bracket. So again, I hope you all know how to do this. I feel like you should know how to do this at this point. And if you don't, then you just need to practice. So I did all that, got this. And then of course this is all still in brackets with a 3, so then I just expanded a 3 into it, and you end up with all this. So with that, we're basically done. We still have to differentiate x to the 4th, but that's really easy, right? That's just power rule. It becomes 4x cubed. So we have this, these 2 lines means, basically this 2 line means this. I didn't want to have to write it out again. Plus blue one, which is all this, equals 4x cubed. So the next step that you have to do is you have to take all the terms that include dy over dx and group them together. So right now, all the terms that we have are on the left side of the equal sign, except for 4x cubed, right? So everything that's purple, right, all this is on the left side. Everything that's blue, all this is on the left side. We want to leave everything that has dy over dx in it, we want to leave on the left side, and everything that doesn't have dy over dx, we want to move it to the right side. So if we look at the purple one here, for example, 2x cubed times dy over dx. So this has dy over dx, so we're going to leave it on the left side. We're not going to touch it. 6x squared y does not have dy over dx, so we're going to move it to the right side, right? So we have 4x cubed here, right, because this is already on the left, minus 6x squared y, because we took this from the left side and moved it to the right side. And of course, if it's addition on the left side, it's subtract on the right side, right? That's just how it works. That's, hopefully you know that. And then we look at this blue one. So 6y to the 5th, dy over dx. That has dy over dx. We're not going to touch it. 3y to the 4th does not have dy over dx, so we're going to bring it to the right side. Here it is, minus 3y to the 4th. 12y cubed x times dy over dx, big old thing. It has dy over dx, so we're not going to touch it. We're going to leave it as is. 6y squared x does not have dy over dx, so we're going to move it to the right side. This is where it is right here, minus 6y squared x. 6x squared y times dy over dx, that has dy over dx, so we're just going to leave it on the left side. And plus 3x squared, that of course doesn't have dy over dx, so we're going to move it to the right side. Here it is. And then what you're going to do, so now you have all the terms with dy over dx on the left side and all the terms that don't have dy over dx on the right side. Since everything on the left side has dy over dx, you're going to take dy over dx out. You're going to factor it out, right? So right here we have dx cubed dy over dx. We kept it on the left side, we factored out dy over dx. 6y to the 5th, right, that's from over here, had dy over dx. We factored dy over dx out. 12y cubed x, that's from right here, 12y cubed x times dy over dx. Factor dy over dx out, and 6x squared y, have it right here, 6x squared y dy over dx. Factor dy over dx out. So you have this, dy over dx times all these things in the brackets is equal to all the other stuff. And then the final step is, so we're trying to find the derivative, right? And the derivative is equal to dy over dx. So to find dy over dx, all we have to do, so we have to take this, right? All this stuff that dy over dx is multiplied by, and remove it from the left side. So you're going to, divide both sides, right? We have dy over dx times all of this on the left. So we're going to divide both sides by all of this. So we divide the left side by all of this, and we're just left with dy over dx. We divide the right side by all of this, and you end up with this final crazy answer. 4x cubed minus 6x squared y minus 3y to the fourth minus 6y squared x minus 3x squared divided by 2x cubed plus 6y to the fifth plus 12y cubed x plus 6x squared y. Now, if you look at different solutions, you will see that they probably factored this a bit. Like this over here, this final answer would be a bit simpler because you'd have some like brackets with square and stuff. And I could do that. I chose to fully expand everything because I wanted to show that even though there's a lot of steps and a lot of numbers and whatnot, it's still just basic algebra. So first you apply, the rules, the chain rule and the product rule, and then after that it's just algebra expansion, straightforward. And so you end up with this answer. It takes a lot of steps, and with a question as complicated as this, there is a pretty good chance that you do end up making a mistake somewhere. You accidentally flip a sign, do this or that. So of course, try to be careful. I think most professors, even if you do accidentally make a mistake somewhere, you flip a sign or mess up, forget a number here or there, as long as you still follow the procedure, I think basically like most professors will still at least give you par marks. So yeah, hopefully this helped, and that's it.